to record. Sorry for that. My apology. Thank you, leadership, Betty. 4.45. 4.45. Now, let's write the hypothesis now. We have the ANOVA, the tabulated value, and sorry for that. We have the tabulated value and the calculated value. So how do we write our hypothesis now? Your null hypothesis will say, this information is there in the study guide. Your H0 will say X2, remember we're testing for X2 here. What is X2 bringing? Whenever we bring X2 in the model, is it making any change in our model? That's what we are testing. So the general statement from your study guide will say, what I'm going to say now is that a general statement. It will say, now because our focus is on X2, variable X2, this one is to be a null hypothesis. Variable X2 does not significantly improve the model after X1 has been included. Variable X2 does not significantly improve the model after X1 has been included in the model. That is your null hypothesis. The alternative hypothesis will say variable X2 significantly improve the model after X1 has been included. That's what we are testing now. So based on your F, which statement is true? Based on your F tabulated and F calculated, I repeat, the null hypothesis will say variable X2 does not improve the model after X1 has been included. And variable, then the alternative hypothesis will say variable X2 significantly improve the model after X1 has been included. Based on your F calculated, which statement is true? Which statement is true between the null and the alternative? Or maybe before I can go to that one, what is your decision here? What is your decision? Are you rejecting what the null hypothesis is saying, or you are failing to reject what the null hypothesis is saying? Leadership Refilo is saying variable X2 does not improve the model after X1 has been included. Leadership's Tato, please, whatever you're writing for the sake of a test, write a full statement. The first part that you said there is correct, but whatever you're writing for the sake of marks, write the statement the way leadership Mukotedi did. Same applies to leadership Raymond. Whenever you're writing for marks, you cannot say fail to reject and you claim that it's a complete statement. For the sake of marks, write something in full. It's like saying your surname is Male, and then I don't include that PE. Obvious, you cannot say it's you, isn't it? Because I didn't include that PE from your surname. Same applies to leadership Tato. If I say your name is Tar and remove the TO, you won't claim that is you. So let's make sure that whenever you're writing for the test, when doing the assessment, please write everything in full, like what leadership Refilo did. It's true. I agree with these three members that we're failing to reject because the F calculated is less than the F tabulated. So this information goes with that we fail to reject the null hypothesis and conclude that X2 does not improve the model. So there's no need for us to bring X2. When we're dealing with the t-test, we fail to reject that there is a relationship between y and what and the age. Even the partial F test, we're getting the same information. Now we've tested for X2. Now we must go and test for what? We must go and test for X1. So you use the same ANOVA table. You just remove what? Now we change the information now. What we're going to do now, we bring in X2. We just remove the what? This color, the purple color. The other information remains the same, except this part here. So now we want to test for X2. For X1, given that X2 is already in the model. After that, we should come up with our final model based on our findings. So now, let's test for X2. Let's test for X1 now with the knowledge of how we've done this one. The upper part here will change. The MSE won't change. So can I please get the value, the SSR of, now we're being told that we're given, what is given now? What is given now between X1 and X2? We want to test for X1. What is already in the model? Which variable is already in the model? We want to test for X1. So X2, so now I'm going to say X2, because we are saying this one is given. It means we have the information of X2. The one that we're testing it means what? Is X1. Given that X2 is already in the model. So what is SSR of X2? We have done, we did this thing yesterday. SSR of X2. From yesterday's class, we've done this. SSR of X2. I'm told it's 49.8711. What is the degrees of freedom of X2? What is the degrees of freedom of X2? It's 1, which means even the other one is 1, isn't it? Partitioning rule. So what is SSR of X1 given X2? X1 given X2? X1 given X2, what is the answer? Is my class rep here? Cleane?
Yes, sir.
Are you aware? You saw the attendance, ne? Don't give me the reason. You saw the attendance, ne?
Yes.
Okay, thank you very much. I don't want us to debate about it, ne? We know the reasons, isn't it, Cleane?
Yes, sir.
Yes, so let's not entertain it. I just wanted to make sure that my leader is aware that the attendance is not good. If we say 30 divided by 298, it's a small number, isn't it? So, can you please give me the F value? The F value, please. Where we agree that this is equal to this value. You can put it again here because you're dividing by 1. So you can do this. I'm told that leadership Tato is saying is 337.07. Can someone confirm that? The tabulated value? The tabulated value? No, sorry, the calculated, the tabulated value is, we have that one is up there. It's not going to change. 337.1. So based on this information, your null hypothesis will say X1 does not significantly improve the model after X2 has been included. And the alternative will say X1 does improve the model after X2 has been included. Which statement is true? Or what is your decision based on that? Are we rejecting the null hypothesis or failing to reject the null hypothesis? You compare your F with tabulated with the calculated one. What is your decision? Leadership, Dan still is saying we reject, we fail to reject. She changed her mind. Now she's saying she's rejecting. I don't know if she's rejecting me or what, but I emphasize that can you please write complete statement. Refile, leadership Ndamini changed their mind. Are you leadership Ndamini? Leadership Refile? Leaders, they are rejecting and they are saying X is improving the X. They have rejected the null hypothesis, rejected reject H0 at 5% level, and conclude that X1 does improve the model after X2 has been included. So now, based on these two ANOVA tables, when you write your, if I ask you to write the final model based on your findings, you only include the variables that are improving the model. The ones that are not improving the model, you leave them out. So what will be your final model? Your final model will have what and what? Can someone give me the final model now based on our findings? We said X1 is improving the model, but X2 is not improving the model. So our final model will be given by what? Guys, are you still there? Thank you, leadership. Leadership Damini is correct. She's saying it's 10. Your beta 0 was 10, leadership. Leadership Damini, your beta 0 was 10. Can someone confirm that model from leadership Damini, if it is correct? But whatever she wrote there, I agree if the values are correct. Your final model won't have beta 2x2. Why? Because we said x2 is not improving the model. So we don't need, there's no need for us to have that variable. When we're using the t-test, we said there's no linear relationship between x2 and y, but there was a relationship between x1 and y. So our final model only contained beta 0 plus beta 1 x1. When we're using the confidence interval, when we're using the confidence interval for of the betas, we notice that the confidence interval for yes, leadership refill.
Afternoon, sir.
Yes, leadership.
Yes, sir. I'm having a problem with you saying that we reject H0 at 5% level, because
Yes.
I don't know.
Yes.
I don't know. So
Which?
maybe
Okay,
like
it's
the
fine. Let me
the,
explain.
the final
Which
conclusion.
is that one is not a conclusion. It's the decision.
Yes,
It's
sir.
the
The
decision.
decision.
The
Yes,
decision. I'm saying we reject the null hypothesis at 5% because you used 5%. The table that you used, the F table, is written how many percent?
it's 5%, sir.
That's where the 5% is coming from. It's very, very important to indicate the level that you use to reject. Why? Because we don't have a proof what will happen if we use the 10% table, the F table, but the 10% one. We don't know what will happen, isn't it? But the one that we have used is the 5% one. For that one, we know since we use the 5% level, we are rejecting. But if I can say go and download 2.5% table, the F table, but the 2.5% one, and ask you what is your decision, you may get different conclusions. That's why it's very, very important to indicate the level that you have used. When you say 5%, you're simply telling us that the F table that I've used is the 5% one. So whatever conclusion I'm giving here is based on that table. Because if I can ask you, what would be a decision if we are using the F table, the one which is written 10%? Will you know the answer, leadership refiller?
Yes, sir. I saw 0.337 and then I recalculated. It gave me 337. So on your screen, I saw 0.337. So I thought
No,
I
no, no,
was
no. No, this
because
one is a mistake. No, maybe it seems I didn't understand. I thought maybe you're talking about why I'm saying at 5%. I thought you were saying, oh,
oh
this one does not exist. This one,
oh sir.
it's
No,
like
sir, because
this.
I was worried on 0. I put 0.337. So when I calculated, it gave me
No, the
337.1.
correct one is 337. I thought you were talking about why I'm saying 5%.
Oh, okay, no
I thought
problem,
your
sir.
argument is on the 5%. Okay, sorry for that, leadership.
Okay, thank you,
So we're
sir.
fine. So
Yes,
we're
sir. Thank
fine. It's
you.
337. We're rejecting, isn't it?
Yes.
So now, if you have noticed, I used the confidence interval of the betas to get the final model. I used the t-test, the hypothesis, the t-test, to be able to give you the final model. I used the partial F test for me to be able to do it, to give you the final model. So we have three methods so far that we can use to check the final model. I can ask you to use the confidence, use the confidence interval method for the betas to test, and after testing, please give us the final model. You should be able to do that one. Or I can say use the t-test to and after applying that t-test, give us the final model. Or I can say use the what? The partial F test. So if I ask you to use the partial F test, you decide to use the T test, it's a problem, because the question is specific that use partial F test. But if I'm not specific which method to use to check for the contribution of each independent of an independent variable, you can use any method provided the given information allows you to do that. If I'm not specific, use any method as long as the given information will allow you to do that. Any question, please? Before I move to the next section, the next section that we're going to do is now, remember, when we started, I asked you to give me some variables that can affect your performance, test performance. So you said you gave me some a lot of examples. So can you please remind me of some of those examples? I said now we are going to write a test, and on the 6th of April. So what do you think can affect your performance there? Can you please list few examples that can affect your performance? In the form of hands, please. Writing, I think, it may take time. We're going to write the test. What variables can be used to measure your performance? Leaders, I'm listening. Lectures attendance, yes. Leadership, Lazarus. Leadership, Lazarus. I know. I know where Lazarus is going, but I know where Lazarus is going, but it can be one of the independent variable that can be used in it. If tutorial lectures were were recorded, what else? Consultations. Let's go. So what kind of information is fine? When coming to tutorial recording, what type of information are you expecting there? What type of information are you expecting there? Or under consultations, what would be the information that is expected under consultations? I mean, the information that you are expecting under consultations, is it a quantitative information or a qualitative information? Under consultation, what information am I expecting there? Is it a quantitative information or a qualitative information? Quantitative, for example? No, it's fine. It's fine. It seems like you're still struggling on maybe trying to understand what I'm asking. So now, you remember, there was a time where I said it's not always the case that we'll be dealing with quantitative information. There will be a time where we'll feel like we can have information that is not numerical, that can be used to predict the dependent variable. Like in our case, we want to sell. This person is selling houses, so you want to buy a house based on the information that is given. But assuming that so far we're told that we're only given the age of the house and the size of the house. We're given the age of the house and the size of the house. That is the only information that is given. What other information which is not numerical that we may need to assess? That's what I'm trying to ask. Can you please give me another variable that is not numerical that we may need to use to predict Y? I assume now my question is better. Based on that, you want to buy a house. What other information that you may need to know before buying that house, which is not numerical? Yes, it's fine. Thank you, leaders. The condition of a house, if it's in a good condition, or if it's not in a better condition, or the location. Location, maybe we can say we want to capture, maybe it's in the suburbs and rural areas, in semi-urban or township. Those are some of the things that can be expected. You may need to know that if you want to buy a house, is the house from a village, or is the house from Santen, and so forth. So now, that is the variable that we want to bring in now. We want to bring an extra variable that can be used to predict the Y. And we're still going to check if that variable is it important in predicting Y. The procedure is still the same, but the difference now will be how we are going to interpret the beta of that variable. Now, what is important will be interpreting the beta of that variable. Remember, if leadership Malepe, if you still remember very well, yesterday, whenever you were defining you were interpreting those betas, you said holding constant the effect of a certain independent variable. Whenever you increase the x by 1 unit, y will be affected. Y will change. The change, we don't know if it will increase or decrease, will be guided by what? By the sign of that beta. But I said, I quote, that statement is only applicable if you are interpreting a quantitative variable. Now we're in a case where we're interpreting a qualitative variable. Now, let's go back to our data set. Let's go back to our data set. Let's say the person who was selling those houses wanted to indicate that if the house that you are buying is having a garage or not. So it means now I want to bring in another variable. Suppose that you have what? Selling price. You have a selling price of the house. Remember, this one is your Y variable. Agree that is your Y. And you have the size of the house, the age. Now we want to bring in the third variable. But this variable now, when we check it, it's no longer numerical. Garage. So the person who's selling these houses is assuming that maybe it's important to also indicate that the houses that is selling, which ones are not having garages, which one are having garages. So now you'll have the price. What was the first price there? What was the first selling price? Can you please go back to the data set and give me first few values from the data set, please? Leaders, last rep, help me. Timekeeper, refill 32. Let's go. 32, 24. It's fine. Let's go to X. Let's go to the size, and so on. Now, let me just say yes. Let me say no. Let me say yes. Let me say yes. And so forth. So this one you are saying is 1.8, 1.7. This is your data set, and so on. Can you please give me the age? 30, 33, 25, and so on. So if you can check, guys, the first three variables are what? The first three variables. This one is what? This one is a quantitative. These three variables are what? Are quantitative. But this one, the garage one now is what? Is qualitative. It's qualitative. It's not numerical. It's what? It's categorical. Okay, thank you. And up to what time, leadership, Smanga? Refilo, can you please help me? Up to 45. Okay, it's fine. Let's break until 3:45. Thank you. Let's break until 3:45 then. According to my clock, is 3:45. Smanga and Refile. Can I continue? Thank you. As I was saying, this last variable, now we can call it what? Now we have three independent variables. We have x1, we have x2, we have x3. So when you check your x3 now, your x3 is not quantitative, it's not numbers. So always, whenever you want to solve a problem, a regression problem, you want everything to be numbers. So now we have to convert this information to numbers. So this when you have this type of information, we call what? We have to introduce what is called a dummy variable. A dummy. So this is, we have to what? Dummy information. So we must come up with information that can replace these words. We have to change this information to numeric. So whenever it is necessary, the coding usually we use 0 and 1. 0 and 1. Let me explain the importance of this 0 and 1. 0 and 1, usually we place 1 when it indicates the presence of something, and 0 when it presents the absence of something. In a case where it makes sense, like in our case, we have yes, the house that you are trying to buy is having a garage. The yes means that the house that you want to buy is having a garage. The first house there. The second house, I said no. The house that you want to buy with 24,000, it doesn't have a garage. You have a no there. So no represent what? The absence of something. But yes represents the presence of something. This logic is only applicable in a case where you are talking about the absence of something or presence of something. In a case where, let's say, you want to change, you want to check the fairness of the salaries that we are receiving as employees of the university, the fairness of the salaries that we are receiving from the university. Someone can claim that no, women are getting more money because of their gender. I'm just giving an example. Someone can claim that no, in our university, we feel like women are getting, even though we are having same qualifications, women are getting more money than men. So what we can do, we can come up with what? A variable called what? Called gender. Under that variable, we're going to have what? If the person is either male or what? Or a female. Male or a female. Male and so forth. We're going to have a variable called gender. Inside that variable, we're expecting information which indicate that the person is a male or the person is a female. These two examples are not the same when coming to the 0 and 1. When coming to 0 and 1, this information is not the same. Let me explain. Let me go back to the garage and explain and relate it what I'm saying with the gender part. I'm saying the meaning of 0 and 1, wherever it makes sense, 1 will represent the presence of something. 0 will represent the absence of something. So there, yes, it means what? 1 will assign 1 for yes, because it's the presence that this house is having a what? A garage. Wherever you see a no, you'll put what? You'll put 0. Wherever you see yes, you put 1. Wherever you see yes, you put what? 1. So this we'll call these values what? Dummy variables, because we changed something which was categorical and we made it numerical. So let's go back to this one of the salaries from UN. Assuming that we have a variable called gender with M representing male and F representing female. How will you change this to numerical using 0 and 1? What will be the order of changing that into numerical? How will you do it? Can someone suggest with a reason? Yes, leadership refill.
So what if we introduced an independent variable where we ask if the person is female, and then in that way we'll just have yes and no answers?
Yes. No, it's fine. Now I understand that one. Now we're having this case. The person is a male or is a female. Which one will take the value 1? Which one will take the value 0? Between M and F, which one will be assigned to 1 or which one will be assigned to 0? Or it doesn't matter? Refiller? My question is that we have 0 and 1. M will be equal to what? And F will be equal to what? That's what I'm asking for.
So can't we say female will be 1 and then male will be 0?
What is guiding you to do that?
Because we're trying to find out which people within the employees are females.
In this case, we were saying females, but yes, the leadership, Munyela.
Sorry, sir. Sir, the easiest way to do it, ne?
Yes.
We have to pick, let's say, if we are gonna be signing a female as 1, ne? Then
Yes.
male will be the one that is representing the gender that is not female. Ne? That will have a yes and a no.
Yes.
Then we can assign the 0 and 1 afterwards.
So if I say yes, leadership, Puto. Siema.
I was
leadership.
thinking that it's not really important.
Sorry?
Can you hear me, sir?
I can hear
Yeah,
you
I
now.
was saying is that it's not really important since this is like a binary problem. So if we have that male, if we have that male is 0, then the female must be 1. Or if we have that the female is 1, is 0, then the male must be 1. Since
Thank you. I agree with you, leadership.
a binary problem, sir.
Thank you. In this case of gender, it doesn't matter which one you assign 1, which one you assign 0, because it's not indicating the presence of something. So someone can say, no, I want my males to be represented by 1 and females to be represented by 0. Someone will say, no, I want my females to be represented by 1 and then male represented by 0. It doesn't matter in this case because it's not indicating the presence of something. But when coming back to the garage part, we said 1 will represent the presence of something. Usually, we'll say 1 represent the presence of something. 0 represent what? The absence of something. But when coming to gender, we're not talking about the presence or absence of something, isn't it? So it doesn't matter which one takes what? The value 0, which one takes the value 1. But if you are directed that, please, for us to have the same answers, wherever you see M, put 1. Wherever you see F, put 0. That one now will get the same answers. But for the gender part, it doesn't matter which one is assigned to 1, which one is assigned to 0. But for the garage part, because we are checking the presence of something, the one which is present will put 1, absence, you put 0. I hope it's clear. My explanation is clear. So now I prepared notes which goes with that. Leadership, Diane, please let's work together for me to share these notes with you guys. To share these notes with you. Yes, so now before I can move to the confidence intervals for the mean and the prediction confidence intervals, I decided to bring what? How do you interpret a quantitative variable? So if you can check now, I only gave an example where we have 2 options. It's either a yes or a no. It's possible that you can have 3 options. Instead of 2, instead of yes or no, it's possible that you can have 3 options. But that one will cover it next week. I don't want to confuse you. I want us to focus in a case where you are having only how many? Only 2 options. We say that yes or no, male and female, and so, as long as you're having 2 options. So now let's check this one. Frequently we wish to use nominal scale variables such as gender. Under gender, you're expecting what? Male or female. Whether the house has a swimming pool. Whether the house is having a swimming pool, obviously expecting what? A yes or a no. Whether the sport team was a home or a visiting team. Even that one, you're expecting what? A yes if it's a home or visiting. What are you expecting there? Guys? Whether a home is when you have this one, those who understand soccer, they will understand what we're talking about when we're talking about home team and visiting team. Guys, don't disappoint me. Represent the ladies. Home and away. It's another word that can be used. If we have a team in Mankweng, based in Mankweng, and then is playing with a team from Boyne, those who are coming from Boyne, yes, it's fine. Something like that. Leadership, Siema indicated there. The one which is from Mankweng, and then the game. If the game is in Mankweng, the Mankweng team, we call it what? A home team. The one that is from Boyne to Mankweng is a visiting team. That's what we're saying. But doesn't matter even if you don't understand this soccer example. What matters is you should understand what we mean by qualitative variables. So this information that is indicated there is called what? A qualitative variable. Those are qualitative variables. The gender, if a house is having a swimming pool, say that it's yes or no. Like the one that we did, if the house is having a garage, it's a qualitative variable. So to include categorical independent variable in regression model, you use what is called what? You use what is called dummy variables. Dummy variables is what you have done when you say change that yes to no, yes to 1, and no to what? and no to 0. By doing that, you have introduced what? Categorical variable. Now we change that to a categorical variable, which is, or we could change it to a dummy variable with a 0 and a 1. But you understand the meaning of that 0 and 1, because when we get to the interpretation part of it, you won't say that the house which is 0. No, 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 no. You must know what your 0 is representing, so that whenever you want to interpret that beta, the way you have assigned the dummies is very, very important, because whenever you're interpreting your betas, we will need um, what you have assigned 1 to. This is the statement that I was saying. It's very, very important. Let's check this one. I said, when appropriate, or when it's necessary, the value 0 is assigned to the absence of something. Like in our case, we said if the house does not have a garage, we'll put 0. If the house is having a garage, we'll put 1. And then 1 will be assigned to if the house is having what? Is having a garage. Same applies to the swimming pool. If the house is having a swimming pool, you'll say 1. If the house does not have a swimming pool, you'll say 0, because it indicates the presence of something. But when coming to gender, if I could go back to gender, it doesn't matter which one goes with 1, which one goes with 0. You see, it doesn't matter which one goes with 1, which one goes with 0. There you can use any. You can say female 1, male 0, or male 1, female 0, because it's not showing the presence of something. So I have an example here. This example is but I don't want us to use this one, or it's fine, we can use this because it's already captured here. So with this data set, you want to develop a model for the selling price of the house based on the size of that house and whether the house is having what? A fireplace. We can change that one and say what? House is having what? A swimming pool. Swimming pool. If the house has a swimming pool, so now we can change this one to what? Swimming pool. I would just want to come up with something that you can picture what we're talking about. Swimming pool. So 1 will say it means the house is having a swimming pool. 0 will say the house does not have what? A swimming pool. So what we are going to change, we are going to do now, is to change this variable to what? To numerical. So what we'll do is that we'll just add insert a column here. Now Excel is troubling me now. Insert. So now swimming pool, SP representing the swimming pool. So wherever we see 1, we see yes, we put 1, because this one indicates the presence of something. So wherever we see yes, we put 1. Otherwise, we put what? 0, 1, 0, sorry, 0, 1, 1, 1. So I will run this using Excel, because what is important, I know you won't fail to find what the model. What is important is to know how to interpret your betas. So I want to copy this to Excel. What we need is the model. I'm coming. Yes, let me share the Excel file. So what is important is on how do you interpret the betas, especially the categorical one. The other ones which are not are still quantitative. The interpretation won't change. Let me share the Excel file. Oh, I have to stop sharing this one. Here is our Excel file. You have the selling price here, the size of the house, and if the house is having a swimming pool. So let's run this. Coming. We have this data set now. So let's try to run this. We'll go to data, and then we want to run this. Our y variable there is assessed value, and we have two independent variables. So we have size and almost done. So this is our model. This is our model. Let me just do like this. The first value here is B0. I'll show you the values now. The second value here is beta 1. The third value here is beta 2. So this is our model, guys. Now let's talk about this model. This is what we're looking for. This information here. Can you see the values, please? Can you see the values? Leaders, can you see the values? So let me write the model for you. Y was what? Selling price. Yeah, I'm writing the model from the weight 16.18 size plus point Manyama Malepe, get ready. I want you to interpret the size of the size of the house, that beta. Now, since you have this information, let me go back to the weight one now, because I captured the model that side. which goes with this data set. This is the model, guys, that we managed to get using that information. So now, can someone explain the meaning of, about the meaning of this 16.18? Let's check the units. The size is in 1,000 square feet. The assessed value is in $1,000. And the swimming pool, remember that one is categorical. You don't have to have the units of that one. So this is the model that we have. Malepe, can you please help me to interpret the size, this part? The size, please. Let's talk about the size now. How do we interpret this beta? Malepe here. Yes, it's in dollars, please. It's in dollars. No, you mean what? The size? The size is in 1,000 square feet. 1,000 square feet, like that last example. The size is in 1,000 square feet, like that last example. Anyone want to try, please? Anyone want to try? It's fine. Let me come in. When you want to interpret the size, you hold constant what? Holding constant the effect of if the house is having a swimming pool or not. Remember, you want to hold constant. If the swimming pool part is held constant, what will happen to the selling price of the house? What will happen to the selling price of the house? It means you will say holding constant the effect of the swimming pool, if the house is having a swimming pool or not. When you increase the size of the house by 1,000 square feet, we expect our what? Our selling price to increase by $16.18 thousand. When you hold constant the effect of the selling price, sorry, of the swimming pool, which is the X2, when you increase the size of the house by 1,000 square feet, which is the 1 unit, the selling price of the house will increase by $16.18 thousand. Now let me move to the new one now, which is categorical. I said that the statement that I just said now of increasing by 1 unit is only applicable when we are dealing with quantitative variables. Now we're dealing with a qualitative variable. So you cannot talk about increasing the swimming pool by 1 unit. If you increase the swimming pool by 1 unit, where are you going? So remember, the information here, it was what? It was categorical. So when you interpret this variable, you focus on the variable that you attached to 1, or on the option that you attached to 1. Remember, you said 1 or 0, 1 or 0. Now, whenever you interpret this variable, you focus on the part that you attached, you assigned 1. In our case is what? In our case is the house is having a swimming pool. So you will say, holding constant the effect of the size of the house for a house which is having a swimming pool, or the house which is having a swimming pool, is expected to cost $3.852 thousand compared to the house without a swimming pool. Let me repeat. A house with holding constant the effect of size of the house, for a house which is having a swimming pool, is expected to cost more by how much? $3.852 thousand compared to the house without a swimming pool. Yes, leadership. Kuto, Siema. Kuto, I think your mic is still off. Unmute your mic, please. Oh, I think it's having a network. It's experiencing network issues. Because I don't know what's happening. Can someone maybe repeat what I've said? I want to check if you understood. Can you please explain this 3.852? Can someone try to explain that 3.852? Interpret that beta 2. Not forgetting that beta is not, it was not numerical, it was what? It was categorical. We just changed it to numerical. So you cannot talk about increasing by 1 unit. Can someone interpret this one? From there, we can knock off. If you get it right, we are done for the day. I can stop here. Can someone interpret this leadership, Christopher?
The swimming pool, sir,
Yes.
I think you will say with holding the effect of size constant, a house with a
Yes.
swimming pool is expected to cost 3.852 more than a house without a swimming pool.
Or you can simply say compared to a house without a swimming pool, isn't it? It means a house without a swimming pool, we won't add that amount, isn't it? So if you want to buy a house without a swimming pool, what are you going to put next to where there is SP? If you want to buy a house without a swimming pool, what will you put where there's SP?
Zero.
Now you want to estimate a house without a swimming pool, what you will put there? 0. Thank you, leadership, Malep. You'll put 0 because you know that your 0 represent a house without a swimming pool. So now if we say, hey, I want to go to Bendo, I want to buy a house there, and then when you test your model, you find that the houses with swimming pools are more expensive. So the only way to estimate the house without the swimming pool, wherever they say swimming pool, you will put a 0. Obviously, the price will go down, isn't it?
Yeah, sorry, sir. Before it cut me off,
Yes.
that was my question, sir. It's fine.
Yes.
I'm answered now.
You are answered. Yes. Okay, leadership, Smanga.
Sir, are we holding
Yes.
the size constant?
Yes. Remember, holding the size constant is saying let the effect of size. We're simply saying, let's say we're not focusing on the effect of size. That's what we mean by saying holding constant. Even when you want to interpret the size, you'll say, let's say I'm not talking about the what the swimming pool part. You say, let's not talk about the swimming pool. I want to focus on the price. Now I can simply say, Smanga, can you please predict? Now I'm coming to you, Mr. Smanga. Can you tell us how much will the house, how much will be the selling price of the house which is having 4 square feet, Let me just write it here. Now, Mr. Smanga, what I want from you is, can you please predict? Can you see when I'm typing, Mr. Smanga? Mr. Smanga, can you predict the price, please? How much will this house cost? Mr. Smanga, can you hear me?
Sir, is 2.5 the size?
Yes, it's the size.
Okay. So this house is going to cost 240.45.
40 point. So convert to this to thousands, it will be what? Give me the exact 240.45.
0.50.
Multiply the 0.50. So it means you are saying the house, which is what? Which is having 2.5 square feet and is having a swimming pool, isn't it, Mr. Smanga? It will cost 2450. So can you please tell me, if this house is not having a swimming pool, how much will it cost? The same size, but it doesn't have a swimming pool. How much will it cost?
Sir, I think I made a mistake. So for that one, you have to add the value for the swimming pool. The one you just wrote now.
Please yes, give me the correct thing.
So I can't say you added the value for the swimming pool that I can add.
Oh, sorry. No, it's fine. Let me go
Yeah.
down. Go down. Where is that fine? Can you see it now?
Yes, sir.
Yes. How much would the house with a swimming pool cost? If it's
Yeah,
having a
it's
swimming pool.
244.302.
So now, assuming that, hey, as Manga, you notice that, hey, this one is expensive. You can opt to buy a house without a swimming pool, isn't it?
Yes.
So how will you estimate, assuming that you need the same size, but you notice that because it's having a swimming pool, it's expensive. So you can say, no, I want the same size, but suppose that even if it's not having a swimming pool, it's not a problem. How much will it cost?
That one, the previous one, it was 240.45.
First one, he said 244.302.
302.
So you see, it's not always the case that whenever you want to buy a house, you only need a quantitative information. You see now, by bringing in the swimming pool part, the price changed there. The price changed there. But what is left now, leaders, is that the change that we're seeing there, is it significant? The change that we're seeing between these two values. You're saying if it's having a swimming pool, it will be 244. If it's not having a swimming pool, it's 240. So the question that I may ask is, based on this, is this a big difference that someone can worry about? Is this a big difference? How do we check for that? If this is a big difference or not? How can we check if this is a big difference or not? What are we supposed to do? We have to go back to the ANOVA table and test for the overall model and check. We have the results, remember? We have the results. Sorry, I want to keep my promise that immediately you give me that answer, I will knock off. I want to keep that promise, but for me to keep that promise, I want to explain this part here. From there, we're done for the day. So, looking at these leaders before we go, let's check these results. Let's check these results. Let's check these results. Why are they not fitting here? Because I want to see the results. You guys, you understand these things better than me. Yesterday, we calculated the confidence interval for the betas, and you told me that you can tell if the variable is significant or not by looking at the confidence intervals. So we have the confidence intervals here. Can you please check if these two variables are significant or not? This is, let me remove this. The confidence interval for beta 1 is that one, the one that I indicated in red. The confidence interval for beta 2 is that one. Based on those two confidence intervals, do we really need all these two independent variables, or we need one of them? Do we need all of them, or do we need one, or do we don't need any? Based on those confidence intervals?
All of them.
Someone saying all of them. What are you saying, guys? The leader said we need all of them. Can you please give us the reason, leadership?
Because 0 is not included in the interval.
0 is not included in the interval, isn't it? So we know now. If I can ask you to give me the final model, you will simply say that my initial model that I started with, it remains. I'm not going to remove anything, because when I check the confidence intervals for the betas, 0 is not included, which means I need these two variables to predict what? The selling price, which means that difference that we saw when we're bringing the 0 and not and when we say the house without the swimming pool will cost 240, it's a big difference, because of what? The variable is significant. It means that variable being there, it is helping us a lot in predicting what? The selling price of the house. Do you get that? Did you get that? Did you get that, leaders?
So can you
Leaders?
repeat?
I'm saying by looking at these two independent, the confidence intervals, we can simply tell if we really need these two independent variables by looking at the confidence intervals, because they don't include 1, so 0, sorry, which means we need them to predict the selling, having the swimming, indicating if the house is having a swimming pool or not. It is very, very important, because those figures, the money, when it changes, there's a difference of $4,000 there. If you check the thing, our findings, there's a difference of $4,000 according to the results. The $4,000 is a lot, so it's very, very important to have these two independent variables. Yes, that one is as long as when we test we find that it is significant, it means we really need that variable to predict why. So with those few words, I want to thank you, leaders, for taking our class serious and coming here. So please, I will share the notes with, I prepared another example that you can use to solve the partial F test. I have an example that I prepared for you that we didn't do in class. I will just share that example on Blackboard, so that whenever you're stuck, you will go to that example so that you can follow to check what is happening. I thank you. Enjoy. Leadership Smart.
Yes. Between the intervals, since you said both of them, they do not include the 0. I want to
Yes.
understand which one is more significant than another. Do we look at the range, or we look at the interval which is closer to 0 or far from 0?
No, you don't compare. You don't compare them. I don't remember a part where we have to compare them. about their scale. This one ranges from this to this. Remember, beta 1, remember, it's categorical variables. There's no way that you can go closer to, so beta 2, it's categorical variables. Beside that, it cannot even go closer to the confidence interval of beta 1. That one is measured in thousands. This one was categorical. Even it's like comparing this one. I should be off record. I can give an example, but I have to stop the recording so that it might take time. I want to release the other members. It might take time. So can I please stop the recording and then I will explain. So those who want to remain for consultation, I'm here until 5 o'clock. We can discuss whatever you want us to discuss. Smang, I think you are one of the people who will be remaining behind because you have a question that will take us maybe a lot of time to explain.